Warm welcome to the technical discussion at Prominence on UPVC windows and door systems. We thank you very much for taking out time for this particular video, and we also thank you for your patience to go through the discussion points in this particular video. So today's agenda for this particular video is we'll discuss about the quality of Prominence UPVC profiles. We'll also discuss about the different factors which affect the wind load which is acting on the building structure. We'll also discuss about the various deflection limits which we consider for the windows, and what are those factors which are affecting this particular deflection limits. We'll also discuss about the basics about the flexuals and what is flexural strength and on what different parameters it depends. That we'll discuss. We'll also discuss about why Prominence design is better, or what are the factors which makes this particular design a good design. So we'll discuss on those particular aspects as well. Okay. So when it comes to UPVC profile properties, the most important part is the E value or Young's modulus, which plays a very crucial role in this particular strain aspect from the wind load and the bending as well as the flexural strength perspective. So let's see some of the test certifications from the institutions where we got tested or Prominence UPVC profiles, which are very good from the perspective of technical specifications or the composition part of profiles, because the ingredients which are used in this particular profile system or the blend which makes this particular UPVC profile system has been best formulation probably possible in this particular arena, and the result itself will speak about the quality of these particular profiles. So if we see testing certification which we got it tested from the Central Institute of Plastics Engineering and Technology, these are the different test parameters you see here, and for these particular test parameters it will also specifies against which standard it has been tested, and at the same time you can read about the results, how these particular results are coming across. So continuation of that is this particular test results. Now the second part of this particular screen, what you are saying, is related more to the mechanical properties of it. For example, resistance to impact by falling mass, if you see as per EN 477, the result is no failure. So obviously this is a good result. So that way you check across, for example, the flexural strength. This particular material as per HTMD 719 MPa is 74.58. So these are the particular figures you can relate across to different standards and the quality of it. So this is most important from the perspective, because once the whole sandwich of UPVC and steel make your window stronger, and for that particular composition, the mechanical properties of UPVC also plays a very crucial and pivotal role. So coming to the wind load part of it, see, if you observe this particular aspects which are given into this particular wind load standard IS 875 part 3, which is the Indian standard for calculating the wind loads on the building structures. There are 5 very important parameters which needs to be considered. The first parameter is the location of a building. In which city your building is located. Whether it's been located into Mumbai, whether it's been located in Chennai, or whether it's been located in North. That way it's very much important to use the location of a building. What we get is something called as a VB, or the basic wind velocity, which is divided into different zones basically. So this particular VB in meter per second is been mentioned in this particular standard, which matters most, or which is basically directly proportional to the end wind load which is coming on the structure. But at the same time, another important factor is the height of a building. If your structure is a ground plus 2, hardly it is 10 or 15 meter height. So the wind load which is coming on that particular height is a much less compared to the building height, which is a 30 or 40 meter height. So this particular standard also specifies the relation with the height of a building, which allows you to calculate in that context. Then another parameter is the surrounding area of the building. Whether your building has been surrounded by a lot of bigger objects, or bigger, rather than bigger objects, it's a bigger buildings or small buildings. So how much dense is the area, or how open is the area? Those are the factors which are also taken into considerations for this particular standard. Then the fourth parameter is the slope near the building. This is also one of the key parameter which needs to be considered while calculating the wind load on the building. Since if there is a slope near the structure, for example, a building is located on the some height or some hill, and then hills have obviously a large slope near it. So the wind velocity which is acting on this particular slope accelerates, and there is a higher pressure accumulation than the normal scenario of a flat land. So that factors also needs to be considered. This particular standard allows certain correction factors so that your end pressure has been calculated based on this particular thing. Also, then again, the fifth very important factor is the life of a building. Whether your building is designed for 10 years life, whether it's been designed for 50 years life, or whether your building has been designed for 100 years life. So based on that, your wind pressure needs to be taken on the little higher side. So this particular factors has been given into this particular standard IS 875 part 3. So we advise that for any of the project you should consider this particular standard and then calculate the actual wind loads which are coming on the different faces of the building, and for that particular wind load you should consider the deflection criteria. So what is the deflection criteria that someone should consider? It's basically given into one of the code IS 8147, which is an Indian code for the structural design in aluminum, which also specifies the deflection limit. Since for the UPVC there is no separate standard, currently let's consider this particular standard, which at least gives you the deflection limit for the aluminum glazing products. Since we are replacing aluminum glazing products in context of windows and doors, we'll consider the same deflection limits applicable for the PVC as well. So what this particular standard specifies is, let's assume I have a window installed in this particular fashion, where this is my UPVC window or door. Which needs to be considered. So, and if this is my direction of a wind load which is acting on this particular window, then this window will deflect in this manner because of this particular wind pressure, let's say WPA in pascals. W is my wind load, which is mentioned in a pascal. So if this is my particular wind load which is acting on this particular window frame, so this will deflect this much mm, and this particular deflection needs to be limited. And how that is to be done? Then this particular standard says, if this is my span L, then this deflection should be less than or equal to L divided by 175 mm. So obviously if this particular profile has a less strength, then it will deflect more than this particular limit. So we'll have to come to the exact profile strength which satisfy this particular criteria, so that our windows is in the safe limits. So let's see. Now what is that property which basically determines the strength of a profile? So we call that as a flexure strength, since this is flexing in this particular direction. So what we are considering is the flexure strength across this particular section. So let's discuss what is the flexure strength in a nutshell. Let's assume you have this particular I-beam which is under load W, and let's say this particular wind load is this particular load is acting on the top face of this particular I-beam. In that case, how much it will deflect is being decided by the property called as a flexural strength of this particular I-beam. So if you consider this particular flexural strength of a I-beam, it will be E into the I times. So I is my yield strength, or Young's modulus, and I is the property which is depending on the geometry of this particular I section, which is called as second moment of inertia. Now this particular moment of inertia will depend upon the area of this particular section and the depth y. So it's basically proportional to the delta A, which is a area here, into y square. So now this is pretty obvious that when your I is a bit, when your y is a larger, then obviously your I will be on the higher side, and since E is a material property, the EI value or the flexural strength increases only with the increase of I value for the same material. So to give a simple layman's language example, if this is one beam and I have a second beam here, and if I am putting a load here on the top of both the beams, then this will deflect less, rather this will deflect more. So obviously the strength is better for this particular design compared to this one. Okay, now let's understand the same factor from the reinforcement perspective. Technically, in case of UPVC, if this is my profile and the reinforcement which goes inside is like this, and my load is acting on this way. So if I consider my reinforcement, then my load is this way. This is my neutral axis. If I consider a small area here somewhere, which is my dA, and if I consider this distance, which is y here, so if my y is higher, my EI value is higher. Since my E value is a material constant, I have a only chance to increase the I value of this particular section. So higher the I, better is the flexural strength of a window. So let's consider how the flexural strength plays a key role in case of a sliding window. If this is my sliding window, and if you take a cross section here, it will be something like this. Is a one shutter, and then there is an interlock section, and there is my another shutter, and my frame is here. So if the wind load which is acting on this particular glass pane, the most vulnerable area is my interlock section, and if my interlock section, if I see it here, my wind load which is acting from this side is being transferred through the glass on this particular section. So my most vulnerable part in case of this particular window scene is the interlock section, which is in the air. So the flexural strength at this particular area matters most when it comes to the strength considerations for the UPVC profiles, prominence UPVC profiles. So let's understand this from the profile design perspective. In case of UPVC prominence profiles, we had kept the bigger chambers inside so that we can put the bigger steels inside. So the steel which goes in this particular cavity can be of this particular size. Whereas let's say if I got a two design choices, which is design A, which has got a more chamber inside for the reinforcement, and design B is where I got a less chamber for the reinforcement. So in that case, my reinforcement goes into this particular fashion. So if I see the direction of a wind load, my direction of the wind load will be from this side. So for this particular direction of a wind load, if I see my neutral axis, this will be my neutral axis for both the profile. Now coming to the flexural strength of this particular profile, this particular area which is from the neutral axis in case of design B is less. At the same time, my distance y also is a less in that particular direction. So compared to this particular composite, the UPVC plus T, the overall strength for this particular design will be less. Whereas if you come to this particular design possibility, then you see I got a larger area of a reinforcement which is away from my neutral axis. At the same time, my distance y also is better than the design B in case of design A. So the overall strength of this particular composite is higher than compared to the design B. So that was the reason why prominence UPVC profiles has been designed around the concept of design A. So all our profiles will follow this particular philosophy so that we get a better strength from the window design perspective. For end delivery of a product, These windows will be much more stronger compared to these kind of a designs. So now you understand why prominence UPVC profiles has a larger chambers for the reinforcement, and why we are focusing from the window strength perspective. Okay. Thank you all for listening this particular video patiently, and we once again welcome you for the other technical discussions in the series, which we likely to present to you for discussing the various technical concepts what we follow at the prominence for a better product delivery. Thank you again.